Hi folks, this is the presentation in the lab in week 2, and of course I won't be here, but the GAs are going to be administering the lab tomorrow. You still have to do your homework, which was made available to you actually last night, in other words on Thursday night I believe, but the GAs are going to be checking your work in the lab tomorrow as you were instructed through the email and through what I said in the class. Now, on the agenda for today is going back to that CCON problem that we did about 4 lectures ago and repeat it with beam elements this time. And there is a few other items that I have discussed in class that I'm going to bring up again, and you're going to have a review basically of those. So this was the problem that we did. In other words, we solved the solid elements, but I told you that if stresses are not of significance to you, then you should be able to do this and should do that as beam elements. So the beam elements are more appropriate way of handling this problem as long as you're not interested in stresses. So this top hole was clamped, and the bottom face was pushed down by 0.01 inch. 0.01 inch. Now remember that this had no planes of symmetry, okay? And this had no planes of symmetry. And on the other hand, if this was the problem that you were doing, in other words, you had a piece like that, and you were pulling this thing up by 0.01, pulling this thing down by 0.01, then XY would be a plane of symmetry. That is not what we have here, okay? In the class, I also alluded to, if this happens to be the case, okay, and XY obviously is a plane of symmetry, what are the restraints? You do only half of this, but what are the restraints that you apply at this symmetry point right there? So XY is a plane of symmetry, therefore there is no displacement in Z, and rotations exactly the opposite. So rotation about X is 0, rotation about Y is 0. Okay, so if you go back there, no translation in Z, no rotation about Y and X. So this is how we use that table. It doesn't apply to our problem because we don't have a plane of symmetry here. Okay, one other thing that you should realize, if you're going to do this thing with beam element, this line should not start here and go all the way to the top. It should go by the median curve here. So 1 inch plus half an inch. So this line for modeling with beam is going to be 1 inch plus half an inch, half of this height. Okay, good. So let's go ahead and start this. Yep. We start with the part file. Immediately save it. File, save management, save as, desktop, new folder, and the new folder is C-clamp with beams. Okay, and say okay. That's fine. Good. Now, the way I'm going to do this thing, I'm not going to put it in a sketch, okay? You can, of course, you can put it in a sketch, but what I'm going to do is I'm going to create 5 points and do it in wireframe. You can do that in sketch. There is no problem with it, okay? But I'm going to do it differently. So let's see, these points, I'm going to make this one, for example. Why don't we start with this? This guy is going to be, as far as the height goes, is 1.5, right? 1.5. We already mentioned that. So let me go ahead here, create a bunch of points. So 1.5 up, okay? Another point, which is from here, but it's going to be 3 in the y direction, okay? Another point is going to be on this side, right? So on this side, for example, I can say y of 1, y of, let's see now, let's look at this. Y of from here to here is 1.5 again. Yeah, 1.5, 1.5, 1.5, and z of 0. Oops, should be minus 1.5 then. Okay, that's better right there. Now these other two I can mirror, for example, if I wanted to, or yeah. So let me do that. Let me mirror them. So there's going to be a mirror. Where is the mirror? So, or the mirroring, if you want to mirror this, then you cannot do it here. So it's better for me actually go ahead and just create the point, okay? So let's go to minus 1.5. See now. Let me see that. This point has coordinate 1.5 up, so it should have negative 1.5. Negative 1.5. What did I do wrong here? Oh, z of negative 1.5. Z of negative 1.5. And everything else is 0. It would have been so much easier if I actually did it with Sketch. But there's a reason. Minus 3. Minus 3 for y. This should be z of x of 0 minus 3. Yeah, I think that should y of minus 3. Let me see. This should be on the other side, right? So that should be plus 3 then. Okay, yep, plus 3. There we are. You got it. Okay. Now, I want to draw my line. The line, there's no problem. I can do it from here to here. There's no problem. And of course, I can also do one from here to here. The problem is with this half a circle. I cannot do half a circle because that becomes a wireframe, right? So what I need to do, I'm going to switch to shape, generative shape design, because here I can do circles in space right there. And the way I want to do it is 3 points, through 3 points. 3 points. This point, that point, and that point. There we are. It was so much easier if we did this thing in a sketch. We have no problem. You can do it in a sketch if you want. Now, on purpose, I'm going to create 2 other points which I want to show you what the effect of it is going to be. One of them is going to be, yeah, for example, this is fine. This is fine. I want it there actually. So z of 0, right there. One of them is here, and the other one is off that plane. So, for example, x of 2. Okay. So these points right now, it seems that they serve no purpose, but you'll see that they actually do later on. One of them will do. Now, do not forget to join. Join this and that and that. Okay, very good. And we've applied material on this thing. Steel on that part. We say okay. Good. Save this thing. I think we already put it in the right folder. Yep. Good. I call it C clamp, remember, with beams. Now we're going to go to generative structure analysis. Okay. we're going to mesh it with beam elements right there. And because we joined it, we can actually do it. The actual element size is, we're going to leave it like this, 0.2. Okay, good. Would you like to see the mesh? Put the cursor there, right click, mesh visualization. You can see that actually it's already there, but if you zoomed in closely, you see that all the node number and element numbers are going to pop up. The middle number is the element number, the sides are the node numbers, but that's fine. Deactivate that. All right, now we're going to do the cross section. 1D property, cross section, 1.5 by 1.5, right? So the support is right here. It's not a circle. It's a tubular, it's a rectangular. And just so that you can see something better, right now, I'm not going to make it 1 by 1. It should be 1 by 1. On purpose, I'm going to make it maybe 0.5. We're going to change that later by 1. Say OK. You see that? Now, notice that I cannot close this without actually selecting an orientation point. So if I select this as my orientation point, it's exactly the way I want it to be. Just look at it. Except that it's not a square. To exaggerate it, I made it 0.5 by 1. But if I selected this other guy, look, just watch what happens with those red cross sections. It tilts. So when the cross section is not a circle, this orientation point becomes extremely important. Now, obviously, this is not what I want. I want that one. And obviously, I don't want 0.5. I want 1 by 1. And I say, OK. And this is the beam version of that. OK, good. So what do we know here? This top point is clamped. Let me hide this. Do not put the clamp on the point right there. And this point, because now the whole thing is, collapsed into a point, is pushed down by 0.01. So let me hide this point first. User defined. Uncheck all of them. That guy in the direction Z, 0, because now I can go change it. Go to load, under enforced displacement, right there. Loads toolbar, enforced displacement. Select that guy and make it minus 0.01 inch. And save the analysis. File, save management, analysis, save as. In that folder, which is the right folder, C clamp IP with beams, and run it. Hopefully we didn't forget anything. I'm pretty sure we didn't. Good. And look at the deflection right there. Let's put it in the front view so that you can see it better. And you can animate it. You say, OK. You can look at the amount of deflection right there. And remember, we talked about this thing in class. Although I'm pushing this bottom down by 0.01, this number is bigger because it not only goes down, it also goes to the left. So this is the magnitude of the displacement vector. That's why it's different. Now, unfortunately, we cannot see the stresses. The only thing that we can see, if you look at this, where you have the displacement, there is stress, principal stress, but unfortunately, the only stress, principal stress that shows us is the axial one, which is kind of useless, okay? And of course, you can change the color here if that's important to you. You can change the color too. Okay. Now, needless to say that, yes, we know that over here there is axial stress, and that's why it's red there. Because remember, you're pulling this thing down. That piece goes through axial stretching. See that? Good. So, the force. Yes, the force. It's exactly the same thing as before. Put the cursor there. Right-click, create resultant sensor, reaction sensor. and it's going to say where. Well, it's this guy, right? It's this guy, which is easier to take it from the tree, right there. It's this fellow. It's this fellow. See, try to pick it from here. You can see that right there, and then you say update, and there's your number. Don't multiply it by 2 or anything. This is the amount of force to take this with the beam element, to take this point and move it down by 0.01 inch. Obviously, it's not going to be necessarily exact as it's not going to be exact as what you did with solid elements, but as long as your solid element mesh was reasonable, as long as your beam element mesh is reasonable, they should be relatively close. Okay. Okay. So that takes care of this problem. Let me close this and go to my next problem. So this, oops, actually these are, okay. Yeah, this is actually a previous test problem, previous one of the years. So what we have here is a problem like this. First of all, the problem statement says use all planes of symmetry, if any, and use the most appropriate element. So when you look at this problem, you should realize that this has to be done with beam elements. Okay? Not with solid elements, although it's drawn for you with solids, but it has to be done with beam elements. Okay, so this problem, then, well, first of all, the symmetry, look at what's happening. Down here, I'm pushing this thing down by, I can't remember, by, let me see. Okay, so we're pushing it down by thousandths of an inch, and we are turning it, twisting it by 2 degrees. Okay, just remember, there's 2 things that we are doing. One is to, oops, one is to push this thing down by thousandths of an inch, and then give it a moment so that it twists by 2 degrees. Part of our job is to find out how much force is needed to pull this thing down and how much moment is needed to actually twist this thing by 2 degrees. Notice that the cross sections are different. Okay, so we know how to handle that. And also there is one plane of symmetry, namely we can cut it with the XZ plane. And as soon as we say XZ is a plane of symmetry, we know that there is no translation in Y, and rotations is exactly the opposite. And that's what this table is, okay? If XZ is the plane of symmetry, no translation in Y, zero translation in Y, and rotations are exactly the opposite. Rotation about X, rotation about Z are 0, okay? Good, so that's how we use this table. So what I'm going to do is, because of the nature of the problem, I'm going to create these points in space, but not all of them. I'll do only the one on the right, and then we move on from there. Okay, so let's go ahead to CATIA here. Start with the part file. And yeah, save this thing. So we go File, Save Management, Save As, Desktop, New Folder, Problem problem 2. Okay. The reason I'm repeating these things over and over and over, because this is what you need to do on your tests. 4 problems, each stuff goes into the right folder labeled problem 1, problem 2, problem 3, and problem 4. and you should expect 4 problems. Good. So let's create a bunch of points. Now these points I can do it in the generative shape design or the part design, and because we only have lines between these 2 points, it really doesn't matter whether you do it here or in part design. If you had a circle, for example, then you would have to go to generative shape design. But anyway, don't forget to join it. At some point, you have to come back here. Even if you did it in part design, you have to come back here because you've got to join the stuff. But let's do that. So I wrote down the coordinates here. So 0, oops, okay. For this is the coordinates of H, 0, tab, 10, tab, 0, one of the points. Coordinates of G is 0, 5, 0, 0, 5, 0. F is 5, 5, 0. Hopefully I didn't make a mistake here. E is 5, 5 minus 10. And that middle point, what I mean by middle point is right here. The place where I cut it is 5 minus 10 and 10. 5 minus 10, sorry, 5, 0 and minus 10. 5, 0 and minus. If there's a mistake, we're going to come and fix it. And cancel. So let's see what we got here. Yep, that looks good. So we have a line going from there to there. A line going from here to here. Another one from there to there. And a final one from here to here. So what I've drawn here for you is this. Okay, good. Don't forget to join. Join these. Okay, and apply material on it. Still on that part. Very good. Save everything. And now we're going to go to generative structure analysis. Okay, we are doing static analysis. This is fine. And let's see now. 1D property, right there. Why don't we make everything as radius 0.15 and then we come and change these things to 0.4, okay? So we're going to support is that, oh, have to mesh it. Notice that you cannot put 1D property without meshing it. See, it won't let me do that, right? Cancel. I forgot to mesh it. Good. And now 1D property, here's a support. Circular, tubal or cylindrical. Click on the wrench, 0.15. Say okay, you can see that right here. See this? 0.15. And then we're going to do local 1D property on these two. So right click, local 1D property on this and that, and click on the wrench and make it 0.4. I just realized something. I think instead of 0.25, that original one should have been 0.15. I'll check that anyways. So we say this. Okay, let's go and check here. Yeah, 0.15. Okay, so that's easy. You just go here, double click, click on the wrench. Oh, 0.15. It is 0.15. That's good. Excellent. Let's save the analysis. File, save management. Here's the analysis. Save as the right folder, problem 2, right? And we go. We say okay. Good. So this endpoint is clamped. Let me hide this. Clamp that. Okay. Let me hide these so that it's easier for me to pick stuff and hide that point. Okay. This is the point of symmetry, right? On what plane? XZ plane. So you go to user define, uncheck everything. This is the point, right? And I'm going to type here symmetry. Symmetry. So it does not move in the Y direction, direction 2, and rotations are exactly the opposite. Okay, good. Then I want to take that point and move it down. So I'm going to click on it, and I'm going to say pushing down, 0 in the direction Z, because I want to be able to change that. And that is the point, right? Good. And then another one, because I want to twist the same point, I'm going to call it twisting it. I'll call it, twisting it by 2 degrees, remember? And twisting it about the Y direction, right? So rotation about Y, we make it 0, because then we can change it. Yep. So here's what we did. Now we want to change some stuff. Change these 0 values that we imposed right there. See that? And force displacement. Let's start with the pushing down. In the downward direction, I can't remember. I think it was 0.001. 0.001. Yes, that's good. So let's go here. 0.001 inch. And click on it. Oh, no, not that, sorry. On the enforced displacement, select the twisting about the direction Y by 2 degrees. 2 deg. Say okay. Save everything. And run it. Done. Let's look at the deflection. Downward deflection right there. I'm gonna let me hide the stuff that I don't want to see. For example, this stuff I don't want to see. Hide and hide and hide, etc. These two. Hide. Okay. So let's animate this. So notice that it's being pushed down, but there's also a 2 degree rotation twisting that's given here. That's why it moves back also. If you look at the view from the front, it should go down also. And if you don't see it, let's exaggerate it, okay? So let me say, okay, exaggerate this thing to be maybe, I don't know, maybe 10. Let's see what happens. You see that? It is going down. It is going down. Okay. But that twisting also, overwhelms the view of that going down. Good. Now we want to know exactly how much stuff is needed, how much force is needed to push this thing down. So we know how it works. So we go here, sensor, right click, create resultant sensor, reaction sensor. So let's see how much force is needed to push it down. This is the restraint that we want, pushing down, and update. Take this, multiply it by 2. Take this, multiply it by 2, about 48 pounds to push it down. Good. Now, what if I wanted to say, okay, good. So Let's do another one. Let's actually, we can double click on the same one. Okay. So under the moment, click on the moment. On the twisting, update, that much moment is needed. That much moment is needed. Multiplied by 2. Don't forget to multiply by 2 to rotate this thing by 2 degrees. Okay? A couple of things that you should be careful here. So what actually goes, yeah, so it's going to be double of that. Yeah. But there's something I wanted to bring your attention to. Let me close this thing. You just have to be a little bit careful. So let me see now. This actually, what I told you needs to be corrected. Let me double click on this one more time. Notice that I'm saying twisting. Yeah, okay, twisting is fine. But let me go back actually and change this. Let me go and change this thing to pushing down. Pushing down. For a moment, see, pushing down on the force, you take 24 multiplied by 2. But there's also a moment here about the, I mean, these units must be changed, of course, but about the y direction, you need to apply some kind of moment. When you push this thing down, true, but there's also a moment due to that pushing down. So you have to take this number, I mean, obviously convert it to pounds, etc. And this has to be added to the other number from the moment. Okay? Say okay. So another one. Under the moment, twisting, moment, it has to be added to this and then multiplied by 2. Okay, that pushing down, because of the nature of the problem, nature of geometry, pushing down not only requires a force downward, but also a moment to keep it in place. That moment has to be added to what you need here for twisting at 2 degrees. Okay, try one more time. So if you look at the pushing down and you look at the moment, 13.8, see that 13.8? That's for pushing down. But if you look at the twisting, under moment, update is going to be that number. So you have to add these numbers up and then multiply it by 2. You have to be a little bit careful here. Okay? If things were, for example, if this sketch was in, if this geometry was in the same plane, then pushing it down would not require a moment. But because of the nature of the problem, that is in the space, it is not in the same plane, then pushing down requires a moment. Okay. Yeah, so that takes care of this. The very last thing that I want to do, I want to make a point of that. The very last thing I want to do is, what if I wanted to solve this problem, but without any planes of symmetry? So let me actually go back to my part. You see, back to my part, right there. Okay. So what I'm going to do is I'm going to mirror, except for this line, which I'm going to delete. Oh, this line I want to delete. Hang in there. Okay, good. I'm going to mirror these things on the other side. Now notice that mirroring of these lines could not have been done in generative in the part design. Okay, but you have to be here in order to be able to mirror it. So where is the mirror? Is this the one? Rotate. Well, I suppose you can do symmetry. Okay, 1, Control 2, Control 3. We're going to mirror with respect to this on the other side. And this line I'm going to make. Okay, so this line I'm going to make from here to here. And I think I still have this middle point. I'm not sure, but let's find out. Hide and show. Yeah, it's still there. Good, good, good. So this is already joined. If not, you have to join this. You have to join all these 5 pieces. Okay, let's go back to the analysis. Let's go back to the analysis. Okay. First of all, it says, I don't understand these because remember, we kind of deleted that stuff. So let's actually go ahead and delete all of these things. Delete, delete, delete. The one thing I have to do is to, and you know what, I'm also gonna do the deleting the property, no problem. Very good. What I'm gonna do is delete the mesh because I want this point to be one of the nodes on that element. So what I'm gonna do is I'm gonna delete this. Now we know what to do. We can't do it here. We have to go to the advanced meshing tool. There we are. Mesh this, no problem. The join. Actually, did I join? Maybe I forgot to join them, or that join was gone. Yeah, when I did all that crazy stuff, the join was gone. So let's go back to the advanced. Let's go back to the part design. Join. Yeah, because when I mirrored it, I had to include these things. Now it's all joined. Now it's all joined. Good. Excellent. Okay, go back to the advanced meshing tool. We are in advanced meshing tool right there. And now we mesh it, all of these things, and include this point. Include this point in the mesh. Good. We say okay. The rest has to be done in the generative structure analysis. 1D property, the whole thing, and that was 0.15. Do you remember that? We go here to 1D property, right click, local 1D property. We select this guy and that guy and that guy and make it 0.4. Yep, good. You can see that the cross sections for these two are different from that. Excellent. And now we're going to clamp that fellow and this fellow and apply a 0 displacement on this point because you want to push it down. Let me hide these things so that it doesn't block me. This point, hang in there. What did I do here? Cancel that for a second. I'm pretty sure I did include that, yeah. Okay, so obviously when I try to put this thing there, it won't take it because there is no 0 downward velocity, 0 downward displacement. So I click on that 0 downward, like that. Yes, right there. Let me call this thing pushing down. Pushing down. Okay. And then also 0 rotation because I want to change that. Same point. Rotation about y0. We call this in twisting. Because now I can go change it. So this guy is going to be negative 0.001. And this rotation is going to be 2 degrees. 2 degrees. Okay. And hopefully we didn't forget anything. Yep. I think we're good. Let me see. There's something here. that is problematic. These two I should have deleted. These were from previous things that I did. So delete that and delete this. Remember, I did this thing twice with a symmetry and without the symmetry. It says that, hey, those things you forgot to delete. I deleted all the restraint, but I forgot to delete the force displacement. Now it should work. Yep. Oh yeah, it says that, hey, you also have some stuff here, so let me delete that. That reaction stuff, it actually ran, but it's just that I don't know what to do with those. So anyway, look at the displacement right there. Okay, animated. Notice that when you push it down and you twist it by 2 degrees, this is how it's going to behave. So yeah, unfortunately, I dug my own grave when I tried to do the same model, clean up the same model. And I did. It's just that I forgot to delete these, the sensors, etc. And you can go and create the sensors again, and it should be consistent with what we got before. All right, folks. Good luck. Don't forget to go to the lab tomorrow.